welcome to the stream. If you are new here, my name is Jarrett, and I am a Rubyist, and I'm working on Advent of Code problems. Don't think I have too much for the preamble today. Yesterday's puzzle was relatively smooth, other than some reading comprehension issues on part 2. Oops. Today we are drinking, I gotta try and say it right. Banahaben? Chaubanach? Or something like that? I don't know. Cowbanach? Something like that. Heavily peated. Scotch. Working through an advent calendar, or a whiskey advent calendar. Two very different scotches in a row. Curious if we'll be back to the international whiskeys after this. I was working to try to get my M1 just MacBook Air set up prior to this in order to use it for, so that I would be able to do the puzzles on it, but unfortunately it has not been playing nice. I'm having trouble compiling Ruby for it due to OpenSSL issues. This is my OpenSSL issues face. So yeah, it's here. You can see if you were to zoom in, you'd see an OpenSSL error. Cannot load such file. OpenSSL. I do not know why it is so upset. I said OpenSSL could not be configured. It will not be installed. Check log for details. I don't know where that log's supposed to be. I couldn't find it. Gotta remove these directories and do some other stuff if you want. Yeah. I wish things just worked. You know? I did not get into programming to fiddle with compiler flags. Surprise, surprise. Yeah, it is quiet. It makes no noises. It just sits there and does things, and it does them quite fast. Haven't really put it to any serious test yet. I did my video calls on it. I did Zoom and Meet and that kind of stuff. Zoom performance was fine. Meet was actually very good. Barely used any battery being in Meet calls. Yeah, just happy so far. No complaints. No complaints except for I can't figure out how to make Ruby install. All right, let's get queued up here. So let's just reviewing the tasting notes for this guy. Feet after a longish day in shoes. Can't say I get that off the nose, though it is pretty strong. I do kind of get the Windex. I can see that, just a lot of smoke though. Like it though, I like it. I like this design we're doing this year. Soviets made whiskeys, eh? It's an interesting idea. Day 10, adapter array. Patched into the aircraft's data port, you discover weather forecasts of a massive tropical storm. Before you can figure out whether it will impact your vacation plans, however, your device suddenly shuts off. Its battery is dead. You'll need to plug it in. There's only one problem. The charging outlet near your seat produces the wrong number of jolts. Always prepared, you make a list of all the joltage adapters in your bag. Each of your joltage adapters is rated for a specific output joltage, your puzzle's input. Any given adapter can take an input 1, 2, or 3 jolts lower than its rating and still produce the rated output joltage. In addition, your device has a built-in joltage adapter rated for 3 jolts higher than the highest rated adapter in your bag. If your adapter list were 396, your device's built-in adapter would be rated for 12 jolts. Okay. Treat the charging outlet near your seat as having an effective joltage rating of 0. Since you have some time to kill, you might as well test all your adapters. Wouldn't want to get to your resort and realize you can't even charge your device. If you use every adapter in your bag at once, what is the distribution of joltage differences between the charging outlet, the adapters, and your device? For example, suppose that in your bag you have the adapters with the following joltage ratings: 16, 10, 15, 5, 1, 11, 7, 19, 6, 12, 4. With these adapters, your device's built-in joltage adapter would be rated for 22 jolts, 3 higher than the highest rated adapter. Because the adapters can only connect to a source 1 to 3 jolts lower than its rating, in order to use every adapter, you'll need to choose them like this. Okay, it sort of goes through and does that. In this example, when using every adapter, there are 7 differences of 1 jolt and 5 differences of 3 jolts. And then they give us a bigger. Find the chain that uses all of your adapters to connect the charging outlet to your device's built-in adapter, and count the joltage differences between the charging outlet, the adapters, and your device. What is the number of 1 jolt differences multiplied by the number of 3 jolt differences? Okay. Excuse me. Okay. All right. Let's do day 10. We will set up our key binding as usual. Generate day 10. The input, which we rarely ever look at. Day 10. Out. And now we can set up our tests because we have 2 tests. So this test sample at input 1. It should be equal to 7 differences of 1, 5 differences of 3, and we're supposed to multiply those together. So 7 times 5, 35. But fortunately, we have a second example today. Longer one. I keep doing that. My indentation is important to me. It shouldn't be in this, but it is. There are 22, so 220, and we can see our tests fail. So we're not gonna mess around with writing a parser, testing a parser, because that's a waste of time. So we have to find an arrangement of these numbers such that each one is less than or they have to increase, right? Because each one can only be the 1, 2, and 3 of these. Only one you have is a 1 or 1. So like, can we just sort them? Am I thinking about this wrong? 4, 5, 6, 7, 10, 11, 15, 16. Oh, there's a, no, that's 3 again. Yeah. I mean, it works for that input. So you could do like input each cons 2, okay, I'm just gonna write this in the, so we have, then we got 1s and we got 3s, and we can do input each cons 2 do a b 1s plus equals 1 if a minus b equals 1, 3s is equals 1 if a minus b equals 3, 1s times 3s. B minus A, B minus A. I didn't sort them. Sure. Oh, we didn't get the right numbers though, so I guess I'm not thinking about this right. Oh, we gotta manipulate the input because we need the first one, we need the 0 and we need the laptop. So let's add let's do something here. Oh, we don't need to add the, if it's 3 rated than the highest adapter, it just means we have an extra 3, so we don't need to care about that. And this is just asking us to insert, wow, really showing off the BIM skills there. There we go. So test that, yeah. So my strategy there was, I figure we don't need to worry about the laptop being 3 higher because we can just assume that there's a 3 jump there because it's always 3 higher, and then I was just missing the 0. So we go through this sorted thing, which I'm sure there's I bet we're gonna have to deal with some sort of change to that sorting or something on this next step. But yeah, and then we just count the differences between the consecutive elements. Relatively straightforward. To completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Yeah, that's what I was worried about. Every arrangement needs to connect the charging outlet to your device. The previous rules about when adapters can successfully connect still apply. The first example above, the one that starts with 16, 10, 15, supports the following arrangements. Yeah. So the charging outlet and your device's built-in adapter are shown in parentheses. Given the adapters from the first example, the total number of arrangements that connect to the charging outlet to your device is 8. The second example above, the one that starts with 20, has many arrangements. In total, the set of adapters can connect to the charging outlet in your device 19,208 distinct arrangements. You glance down at your bag and try to remember why you brought so many adapters. There must be more than 1 trillion valid ways to arrange them. Surely there must be an efficient way to count the arrangements. Intriguing. Well, not 1 trillion, because they have to increase. So let's commit day 1 or day 10. Part 1, and put the air to the side so we don't spill whiskey on it. Okay. So we can kind of do the same thing for part 2 here. Let's just copy these completely. It's fun that they gave us 2 whole test inputs for this one. So this one is 8, and this one is some much larger number that I did not memorize. Okay, and we'll remember to remap our thing to run part 2 so we don't make that mistake again. Okay. I'm gonna sort these out the gates. And I'm gonna just introduce a max or a laptop, which is input.last plus 3. So we've not broken our implementation by doing that. That might come in handy. So we're looking to count solutions. We found 0 of them so far, and we are going to return the number of solutions at the end. Yet again, I feel like reaching for recursion. So or so am I doing this? So okay, one thing I just wanted to check while we're here is input length. Oh, that's not, I want the actual puzzle. Okay, so there are no duplicates. It's good to know. So if we pass in, so let's say we're trying to count the solutions. We want the solutions starting at 0 for our input, and then solutions current input, and we want to return so if let's add on laptop onto the end. So if we want to just return 1 if current is laptop. So that's our base case. It means we've gotten to a point in this chain where the I guess I don't even call it inputs. Why did I call this input? Chain. We'll just call it chain. We've gotten to a point where we're at the end and we've successfully connected to the laptop. Otherwise, we want whatever the valid next options are based on I mean, current and chain's not ever changing. I don't know why I've done that. Putting that in a method because it doesn't ever change. I don't need to pass it down all the way. So whatever the valid next options are, we want to map them to the number of solutions for that option and sum that. And then to determine the valid next options, we want chain. I mean, we might need to do optimizations here, but I'm gonna do like the naivest thing I can do here, and say delta equals new number minus n, and one to 3 include delta. arguments given 1, expected 2. Yep, I didn't update the API to that. And valid next options does not take the chain. And my tests pass, but the solution is slow. How slow is it? Let's briefly switch to my face, or just take a little peek at HTOP, which has pinned my CPU. Okay, so that solution probably not computationally viable, or I've made a mistake. But I like that it works for the small numbers. It means, like, presumably my thinking is correct. It's just searching this. It does, yes. What am I gonna do? How do I tackle this in a... Oh yeah, today's whiskey is very good. It is real peaty. All right, how do we do this? Efficient way to count them. Thank you. What am I missing? Come on. Like, my searching the array every time is really slow, but... I'm just writing this while I'm trying to think of so we can memoize that terribly slow thing. I don't think that's going to make it fast enough, though. Because I think we need to do something much more clever than that. But what is it? Any thoughts, chat? What do I need to do here? Entrance. Oh, do I need to do it backwards? Should I make it easier? Well, the way I've done it is computationally impractical. It's not going to finish fast enough. There's too many possibilities. I feel like reversing it helps me though. What is the trick here? So dang it. What am I supposed to do here? I am blanking on this one. Not really, I think. There were no computationally tricky parts in part 1, so like all of the things I'm thinking of are just different ways to do roughly the strategy I'm picking. Like just more efficient ways of doing it. Like, okay, I could pass the remaining chunk of the input down, which like I was initially planning on doing. But that doesn't really help. Like I'd be able to use like take while to grab the first the next the next possible steps rather than searching the whole array. But I mean, maybe I'll try that while I think about it, because I don't think that's not meaningfully different than what I'm doing. Okay, so oh, I can't use next. Jane. Just use, I don't know. Okay, so we'll pass in that. Is there a repeated subproblem for each step? I mean, finding the next inputs, yeah. Do I just need to use more memoization? Is that what I'm missing? I feel like that's not, I feel like I'm just like not quite there. So then if it repeatedly gets to the same one, it will have memoized the value and return it again. Oh, there you go. Oh, thank you, Hoff. There we go. So I wasn't thinking about how many times we would, or like the order of how we were traversing that, and how doing recursion like that is just going to cause us to like hit the same numbers over and over and over and over again. So thank you, Hoff. Thank you, Mamesy. That one went relatively quick, only half an hour. I will be back again tomorrow evening for yet another round of Advent of Code adventures. Thanks everyone for coming, and see you tomorrow.